One of the goals of this section is to be able to draw a rough sketch of a graph of a polynomial function of a higher degree. So that's what we're working towards. At the bottom of page 2, we're going to start discussing what does the graph of a polynomial look like. Okay, as I've mentioned already, this whole entire time we've been working with polynomials, we just didn't call them that. So the first bullet point there says, what does the graph of a polynomial of degree 0 look like? Okay, well, if you remember, if you go back up to the table in example 1, we saw a 0-degree polynomial, okay, right here. Okay, look at this one. Okay, let me highlight it. Okay, this box. Okay, so we learned that if you have 2 as your polynomial, that's a 0-degree polynomial because you can write it as 2 times x to the 0 power. Remember, anything raised to the 0 power is 1. Okay, so anything that's just a number is a degree 0 polynomial. Okay, so let me write that down over here. So for degree 0, because we're trying to figure out what this looks like, let's look at the function f of x is equal to 2. Okay, well, remember, this is the same thing as y equals 2. So think back to this section on lines. Remember, we saw x equals, and then we saw y equals. And if you remember the difference between the two, y equals is a horizontal line because you can write this as y equals 0 times x plus 2. So you see that y equals mx plus b form there. And so if you were to graph this out, so let me put in some axes on here. So if this is your x-axis, and then I come in with the y-axis, okay, this is going to be a line with slope 0, so that means it is a horizontal line, and it has a b value of 2, and so it has a y-intercept of 2, and it's just this horizontal line going through that point. Okay, so that is what a polynomial of degree 0 looks like. It is just a horizontal line. Okay, all right, what about degree 1? Okay, so what I want you to do, and I'll put this in a different color, think of something in your head. Think of a polynomial that's degree 1. Okay, so the highest power of x in the whole thing is 1. Okay, so I'm going to make up something. So for degree 1, let's say we have the function f of x is equal to 2x plus 1. Okay, the highest power of x in the whole thing is 1. Okay, so we know this is y equals 2x plus 1. This is nothing more than y equals mx plus b. Okay, so it's a line as well. If you were to graph this thing out, okay, and I'm just drawing a rough sketch. So if this is the x-axis, and then we've got our y-axis, okay, you would have a y-intercept at positive 1, and then you would go up 2 and then right 1 to get a slope of 2. Okay, so this graph would look like this. It would have your line would go through 0, 1 and 1, 3. Okay, so here you go. Here's that line. Okay, so you get another line. So what's the difference between degree 0 and degree 1? Because you get lines in both cases. Well, in this case, this is a line with non-zero slope. Okay, so your line is going to have some kind of slope to it. All right, so moving on. What does degree 2 look like? Okay, so again, make something up. Okay, so up here, I'll go ahead and say for degree 2, just write down a polynomial function. The highest power in the whole thing is 2. So x squared plus x plus 1. Okay, I'm not going to sketch it out, but well, exactly, but we know that anything with degree 2, highest power of x is 2, it's quadratic. Okay, so this is going to be a quadratic function. Okay, so we know that this is going to be a parabola. Okay, some are going to open up and some are going to open down. Okay, but if you're dealing with a polynomial function of degree 2, you're dealing with a parabola. Okay, so we've done all of this already. Okay, so what we're going to get into is higher degrees. We have mostly concentrated on degree 0 and degree 1 and degree 2, but now we're going to start looking at degree 3 and degree 4 and degree 5 and degree 6 and so on. Okay, what do these higher degree polynomials look like? Okay, all right, so just remember as we go forward, degree 0 is a horizontal line. Degree 1 is y equals mx plus b. It's a line with non-zero slope. And degree 2 is ax squared plus bx plus c. It's a parabola. Okay, so let's start talking right here about the higher degrees, meaning 3 and above. All right, so we're going to talk shape first. Okay, so basically all the odd degrees are going to look similar. All the even degrees are going to look similar. Okay, so we're kind of pooling them into this category. Is the degree even or is the degree odd? Okay, so let's talk odd degree. Okay, so if you're thinking about an odd degree, so I'm going to come up here. Okay, so let me see if I can find myself some room. If we're talking about odd degree, okay, I'm going to write down the most basic function, the most basic polynomial function of odd degree that we have seen before that's got a higher power, and that was f of x is equal to x cubed. Okay, so if you remember what this guy looks like, okay, that was that S-shaped graph. Okay, so that's how you can remember this. X cubed, the degree is 3. It's an odd degree. So anything that you have with an odd degree, if it has an x to the 5th, or if it has an x to the 7th, or if it has an x to the 9th, and so on, anything with an odd degree is going to have an S shape. Okay, so I'm going to go ahead and write that down. Okay, it says, oops, I put that in the wrong blank. Let me erase it and then read through the sentence again. It says, for higher degrees, if a polynomial has an odd degree, its graph is S-shaped. Okay, now, even degree. Okay, so like I said, guys like x squared, x to the 4th, x to the 6th, and so on, they're going to look similar. Okay, so here we go. I'll put this in a different color so you can distinguish them. So if I'm dealing with even degree, okay, again, we're going to think of something really basic that we've seen before. X squared. I know it's not a higher degree, but you're familiar with it. We know that x squared looks like this. It's just a parabola. Okay, parabolas are U-shaped. Okay, now once you go into the higher degrees, as soon as you hit x to the 4th, for example, it's going to get more complicated in that U might turn into a W. Okay, so I'm going to put U comma W, and then we can bring in transformations. So, you know, if I were to flip the blue graph, I might get something like this. Okay, so we could also see ilm shapes. Okay, so that's what you can kind of expect if you are working with a polynomial function of higher degree and it's an odd degree. You can expect some kind of S shape. If you're dealing with a polynomial function of higher degree, you can expect an even degree polynomial to have either a U shape, a W shape, or even an ilm shape. Okay. All right, more characteristics of polynomial functions. If we look at this next bullet point here, it says the graph of a polynomial function is a curve that is always blank, meaning that the graph contains no sharp corners or cusps, and blank, meaning it has no gaps or holes and can be drawn without lifting your pencil from the paper. Okay, so let me go ahead and fill in the blank, and then I will talk about each of these characteristics. Okay, like I said, we're working towards learning how to draw a rough sketch of a polynomial function of a higher degree. When you draw a polynomial function, it needs to be smooth and continuous. Okay, what smooth means is that it contains no sharp corners. Okay, what is a sharp corner? Well, think about if you go sit down in the corner of a room. Okay, it's going to be something like that. Okay, so remember our buddy, the absolute value function? It has a sharp corner, so that's why it's not considered to be a polynomial. Okay, what a cusp is, okay, it's something that looks like this. Oops. Okay, so maybe like two humps that come to a point in the middle. Okay, So your polynomial cannot have those characteristics. It cannot have a sharp corner. It cannot have a cusp. Okay, it has to be smooth. Cannot have those things. Continuous. That is a word that we saw associated with piecewise functions. So remember, if something is continuous, you can draw it without picking up your pencil. Okay, so when you draw your polynomial out, it, it can't be broken. It can't come in pieces. If it comes in pieces, then they have to be connected essentially. Okay, and again, they can't have any sharp corners or cusps. Okay, so what I'm going to do now that we've talked about smooth and continuous, those are two huge characteristics of polynomial functions. I have two blank grids here, and I'm going to illustrate something that is a polynomial and then something that is not a polynomial. Okay, so here we go. If something is a polynomial, okay, every time, everything's got to be rounded out and curvy. Okay, so something like this would be a polynomial function. Okay, something that is not a polynomial function, we already said absolute value because it has a sharp corner. If I drew this, okay, let me draw something on here like this. Okay, so say we have this and then we have something that does this. Okay, so this is a piecewise defined function. Okay, if I draw this thing, I have to pick up my pencil in order to draw it. Okay, so this is not continuous. Okay, so it's not a polynomial. Okay, again, if I drew anything else like that had a cusp or a sharp corner, that would disqualify it as well. But remember, when you draw your polynomial, it has to be smooth and continuous. You want everything to be flowy and rounded out essentially. So this is good to go, but this is not.